In the previous video, you got a chance to see how we name alkanes. So really just looking at simple carbon-based compounds that are made up of a straight chain of carbons connected with single bonds. But those chains can be a little bit more complicated, and that's what we're going to take a look at today is when we now replace that single bond to a hydrogen in one spot with a bond to a carbon. Since carbon is able to form 4 bonds and it's able to bond to itself, it means that you can actually have branches that come off of a main chain of carbons. That's what we call an alkyl group, and to identify what those alkyl groups are and where they go in compounds, we actually add to the naming system that we learned previously. So when it comes to using an alkyl group, we look at the length of that alkyl. So what this means is you would find your longest chain of carbons and then find a branch that comes off of it. If that branch is 1 carbon long, we would add the prefix methyl in front. If the branch was 2 carbons long, we would add the prefix ethyl. 3 carbons, propyl. 4 carbons, butyl. So you can see we're using the same prefixes as when it came to alkanes. To show that it's an alkyl group, we add the YL to the end of that little prefix to show that it's a branch coming off. Now, if you're taking higher level chemistry, like maybe doing this in university, the propyl and butyl and higher alkyl groups actually have multiple names because they can come in multiple different versions. But at this level, we're keeping it as simple as we can. And so we're just going to stick with those 4 in order to help make things a little bit easier. So when it comes to naming a compound that has an alkyl group in it, what we want to do is really kind of follow a set of rules. So number 1, you need to find the longest chain of carbons. The longest chain of carbons is what we consider to be the main chain and gets the name at the end to identify that longest part of the molecule. You then want to use just our prefix and suffix system that we learned previously. So is it like methane? Is it butane, octane, whatever? Make sure you use that. Then identify your alkyl groups that come off of that chain, and you need to find the position of those alkyl groups. So you're going to number the longest chain of carbons, being sure to use the lowest sum of numbers when it comes to numbering the alkyl groups. So you want to number them as low as possible when you're doing this. The next thing you want to do is you want to name your alkyl groups at the beginning of the name. And so I know this is a little bit complicated, and I know there's a lot of rules, and there's going to be more rules eventually, but we'll work through some examples, and then hopefully that will help make sure that you understand how to do this. So I have a couple examples here, and what we're going to do is we're going to work through and figure out the name of these compounds so that we can identify what they would be. Remember, there's only ever one name for any organic compound, and so as long as we follow the rules, we'll be able to figure out what that name is. So we're going to start at the top with this one. This will be my number 1. What we want to do is we want to name this compound so that we can follow all those rules and make sure we come up with the proper name. The first step is finding the longest chain of carbons. And so what you want to do is count through and find the longest continuous chain. So it should be fairly clear here, but I'm going to show you that it's not always so clear. Like, what if I went 1, 2, 3? Well, clearly that's not my longest chain. So then I could go 1, 2, 3, 4, 5. That is my longest chain. You could actually also go 1, 2, 3, 4, 5. It doesn't really matter. But for the sake of simplicity, we're going to look at this section here being the longest part. And that makes up my main chain. And so I'm going to give it the name at the end. So since it's 5 carbons, it's going to get a name that starts with pent. And because we only have single bonds in between those carbons, I'm going to use the ending ANE. So I'm just going to rewrite that, make it a little bit clearer. So the ending of the name for this compound is pentane. Now, it's not pentane though, because there's more going on. It's not just 5 carbons straight across. it has this little branch. So this little branch that's sticking off of the side is made up of one carbon. So that means it is a methyl group. So what that means is at the beginning of the name, I would actually write methyl. Now, when I write it, I actually don't even leave a space. It's all one word, so methylpentane. But I'm not done yet. That group needs a number because I need to tell people where it is. So let's look at how we can number this. When you number it, you always number the longest chain. You have to start on one end. You can't start in the middle. And then you count across in order to try and get this the lowest number that you possibly can. Now, it's kind of simple here, but I'm going to show you in both directions. So we can make this carbon number 1, this carbon number 2, 3, 4, and 5. We could also do this in the opposite direction. So let's pretend we said this was carbon number 1, this was carbon number 2, 3, 4, and 5. Well, you can see if I were to use the green numbers, I would number this 4-methylpentane. If I were to use the red numbers, I would call this 2-methylpentane. Since 2 is less than 4, it means that in the name of this compound, we are going to call it 2-methylpentane. Now, every time you have a number next to a letter, it gets separated by a dash. And so this is called 2-methylpentane. There is actually no molecule called 4-methylpentane, because if you used a 4, it actually just means you numbered, or you gave this the wrong name. It means you numbered it improperly. So that's what this is going to look like. So let's do another example. We have another molecule down here. It has 1, 2, 3, 4 different, or 4 carbons inside that molecule. So that's our longest chain of carbons is the 4. And so I'm going to call this some kind of butane. Now we don't know exactly which butane yet. We have to look at it. So I have one branch here, and this branch here only has 1 carbon. I have another branch here that only has 1 carbon. If it has 1 carbon, then it has to be a methyl. So the beginning of this name is going to be methyl butane. But I have 2 of them, and to represent that there are 2 methyl groups, we use a prefix in front. And so I would actually call this dimethyl butane, because there are 2 methyls on a 4-carbon chain with single bonds. But where are they? So you could go carbon 1, carbon 2, carbon 3, carbon 4, and actually let's just do that. Let's number it. So let's say we did carbon 1, 2, 3, and 4. It means that I get a carbon on the 2 and a carbon on the 3. I could also name it in the opposite direction and go, this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. And that still gives me on the 2 and the 3. If you were to add them up, remember we want the lowest sum, you get 5 either way, which means it actually doesn't matter which direction you use because it's actually the same. So what I would do here is call this 2, 3, and because I have 2 numbers next to each other, I use a comma to separate them. So 2,3 dimethylbutane and a hyphen or a dash in between a number and a letter. So 2, 3 dash dimethylbutane. That's how I would name this compound. So as you can see, use numbers. Give the lowest number you possibly can. Use your alkyl prefixes to identify how big those branches are. Use the suffix and prefix method that we learned before. Commas and dashes are used to separate numbers and letters. And so these are some more simple examples, But I also wanted to point out, if you were to actually do something right now, and I'm going to move my camera a little bit so I have a little bit more space. If we wanted to find the molecular formula for each of these, what you would find is that it is C6H14. And this one, C6H14. And if you watch my last video, you also know that hexane is C6H14. Molecules that have the same molecular formula but are structured in different ways are called isomers. And so these are all isomers of each other. They're different ways of connecting the same number of atoms. This actually leads to them having different properties. Molecules that have the same molecular formula may actually do totally different things. And so that's why we have this naming system, is because they're different, we have to be able to identify them by more than just that molecular formula. We're going to take a look at one more example that's a little bit more complicated and adds a little bit more to it. And so let's see how we would name something like that. So this is the compound that we're going to try and name. And so you can see we got a few more things going on here, and we're going to work through how you would actually tackle a problem like this. So remember, your first step is find your longest chain of carbons. Now, I imagine a lot of people, when they first saw this, went, okay, 1, 2, 3, 4, 5, 6, some kind of hexane. Well, keep in mind, a chain of carbons doesn't have to go straight. It can actually curve and change direction. So 1, 2, 3, 4, 5, 6, 7. This is the longest chain of carbons. And so what that means is this is a branch, and this is a branch. These two branches are actually different lengths. So we have methyl and we have ethyl. A 2-carbon chain is called an ethyl. We also have this 7-carbon chain, and so let's think about what the main chain would be called. 7 carbons is hept. They are all single bonded, so ane, so heptane. Now let's think about our numbering system. So we could number this going carbon number 1, carbon number 2, 3, 4, 5, 6, and 7. We could also number it going 1, 2, 3, 4, 5, 6, and 7. Using those red numbers, I would have branches at the 2 and at the 4 position to give me a total of 6 if I were to number that way. If I were to go the other way and use green, I would use a 4 and a 6 to name it, which gives me a total of 10. That tells me I don't want to use the green numbers. I want to use the red numbers because those are the ones that give me the lowest sum. So I'm actually going to even erase those green ones so that we don't even think about them and they're not confusing and mixing us up. Okay, so then what we want to do is we want to add the name for that, and we have 2-methyl, 4-ethyl. What we're going to do is put the ethyl at the front of the name because alphabetically it comes before methyl. So if you have more than one of these things, the one that alphabetically comes first goes first. I want to point out here though, if you were to say let's have like diethyl, we still use the actual prefix name. We don't use that in the alphabetical order. You just use this. You would still add this to the name, but you count only the beginning as the alphabetical part. So what we're going to do here is we are going to have 4-ethyl, 2, ran out of room here, 2-methyl, heptane. You can see dashes separating every number and letter, and we have each of our branches written down. We have our main chain written down. One thing that you'll probably hear me talk about a lot is that an organic name should tell you the story of that compound. If I were to read this, every piece is actually telling me something. There's no extra information here. I know that in a 7-chain compound, or a compound with 7 carbons connected that are only single bonded, there is a 1-carbon branch off of the 2nd carbon and a 2-carbon branch off of the 4th carbon. So just by reading this name, I can actually figure out what this would be because all of this information is telling me about that molecule. So this is how we name when we have alkyl branches, and hopefully this helps. And I'll see you next time.